Welcome to part 2, YouTube viewers. This is Edgar again. We're going to continue on with the times 100 voltage amplifier in this VinyLiberator Blue Collar Economy Edition phono preamp. Since it's here, we'll go into more detail on the power supply section. We have a 0.1 in here from the negative 5 volt rail to ground. There's also a 0.1 on the positive 5 volt rail from positive 5 to ground. Excuse me. Okay, the capacitors from the rails to ground at each chip are bypass capacitors. Us older folks, we also call them decoupling capacitors. And what they do is they shunt any high frequency noise and interference to ground, and they greatly reduce the tendency of an amplifier to oscillate. So they tend to clean up the noise and stabilize the system. The coupling capacitors I'm using on the output, and they really don't do much. This point is supposed to ride at 0 volts DC, and because I have an AC feedback and it's dividing the voltage by 10, and I don't have an isolating capacitor, it means that the DC feedback is also divided by 10, and DC gain is also 10. So it tends to amplify whatever the offset is at the input circuit of this IC, and it also floats at about 300 millivolts above zero, and that would cause noise as you're connecting and disconnecting the amplifier after this, because you'd be having 300 millivolts of DC cutting in and out. So I'm showing a 3.3 microfarad, but actually, because I do VLF, I'm also using the 1.5 microfarad. I usually just buy a bunch of 1.5 microfarad. In this case, since I need about 3 microfarads, I'll put a couple of them in parallel. So, as you've seen so far, no part of the audio chain in this preamp uses electrolytic capacitors. So that has a tendency to reduce noise and distortion. And I'm using a 3.3K resistor after the capacitor. If you run a low load impedance on this thing, what it'll do is it'll lose low frequencies, because the reactance of the capacitor tends to go up as the frequency goes down, and this resistor will keep the load on the output side of the capacitor above 3.3 K all the time. And what that'll do is allow the frequency response to go on down to 20 hertz without loss. And it just means if you try to run into too low of a load impedance, it's just going to allow the output voltage to drop. But that resistor will keep it from losing low frequency, so it'll keep the output load from affecting the frequency response. Now, my client that I'm proposing this to is going to want a mono switch, so the action of these resistors will also be really conducive to a mono switch working well. Mono switch just from the high side of the left channel to the high side of the right channel, you close it and it goes into mono, and the scratches and part of the record noise will be canceled out. So that's pretty much it for the times 100 amplifier. The 100K here, like I was saying before, gives the DC path for the bias, so the amplifier will be biased. 0.2 capacitor here keeps the 300 millivolts offset from stage 1 from driving this all the way to the top rail, and that also allows it to tolerate TLO72s instead of using those expensive OPA 1642s for stage 1 and those expensive LM9562s for stage 2. And the difference between the expensive, what would we call it? We'll call it chipset. The difference between the expensive chipset and the economy chipset is only a few dB. It really doesn't justify the cost. So from now on, I'm not even going to use them. When I'm playing this at the loudest level I can stand, where it's clipping the amplifier, when the music stops, can't hear the amp hiss, can't hear the hiss from the preamp until you turn the gain up way above what it would take to clip the power amp. So that indicates to me that it should easily be 60 dB or better of a signal to noise ratio. We'll pause, and then we'll go on to the power supply circuit. Got 2 minutes left on the disc, and we need to do more recording, so it looks like I'm going to change the disc too. So